Okay, what about when you have a power to a power? So a to the m to the n power. How did you combine those exponents? Multiply them. What about in division? How did we combine our exponents? Subtraction. What did we do when we had a product of things with a power on the outside? You put it to everything. So a to the n, b to the n. What about when it's division with a power on the outside? You know this. Same thing. You put it to everything. A to the n over b to the n. What about negative exponents? I know you know this one because we've used it this year. Fraction. 1 over a to the n. And then last one, a fractional exponent. How can we rewrite that? As a radical. So we write this as the nth power of a to the m. You could also write it as the nth power of a with the m on the outside. Okay, these are the properties that we're going to be using today. I'm just using them in a lot of different ways, but it's all going to come back to these 7 things. Actually, there is one that I did not do, but I know it comes up in the notes tonight, so I'm going to add it here real quick. What's a to the 0? 1. Okay, anything to the 0 power is 1. So, like I said, if you guys seem to be getting these, I'm going to skip around. If you need me to go through one in particular, let me know, just because I'm not sure how much you remember versus not remember. So let's see. 36 to the 1/2 would be what? 6, because you write it as the square root of 36, which is 6. What about negative 25 to the 1/2? Which one is it, negative 5 or 5i? Huh?
Wait, doesn't it want other numbers? That's where like some
Oh, I'm not looking at the homework. We're just simplifying right now. I'm not looking at the directions on the homework or on the assignment classwork. Is the negative have the power on it, or is it just on the 25? It's just on the 25. So the negative would just be negative 5. Now the difference here, see how the negative's in the parentheses? That's 5i. Because we'll rewrite this as square root of negative 25. So make sure you watch your parentheses, because that will make a difference between whether you have an I or not. Okay, what about 4? How can we rewrite that? Can't do it in your head, that's fine. Just go ahead and take it a step at a time. If it's a fractional exponent, what's the first thing we want to think about doing? Do the radical cubed root of negative 64 squared. Can we take the cubed root of negative 64? What is it? Negative 4. You can cube root a negative. You can't square root a negative, but cubed root works okay, because you're looking for what number times itself 3 times. So negative 4 times negative 4 times negative 4. So then what's negative 4 squared? So how do you think 5 is going to change? Because it's almost identical, just one's in parentheses, one's not. Robert? The 64 is going to be positive. What happens to this negative? It just stays on the outside. So we have negative on the outside, cubed root of 64, and that squared doesn't go with the negative either. That negative doesn't have the power on it at all. So we'll have the cubed root of, the cubed root of 64, and it's positive. So we get negative 16. Okay, what about something like number 6? How might we simplify that? It's actually harder to do the inside first on this one. Tyler?
Times all the exponents by 1/4.
If we use the property that says we put this power to everything on the inside and multiply, what's 4 times 1/4? 2 to the first. And what's 12 times 1/4? 3 to the third. So then we end up with 2 times 27, which would give us 54. So yeah, we could, but 3 to the 12th is a really big number. So sometimes you want to think about not doing that first. Okay, what about 7? What should we think when we have a fractional exponent? Rewriting it as a radical. That's kind of when you're simplifying and you see a fractional exponent, try rewriting as a radical. So I'm going to do the square root. I'm also going to change the decimal to a fraction. So 0.01, what is that as a fraction? 1 over 100. With the cubed on the outside. Why do you think I wanted to change it to a fraction instead of a decimal?
Because we can do square root of 100.
Because it's a lot easier to square root top and bottom here when it's in fraction form. So square root of 1 over 100 is 1/10. And then raise it to the third power. You get 1 over 1,000. Number 8 is the same way, but it has a negative exponent. So what would we do with that one? Not negative. So this one, again, start by rewriting it as a radical. So the cubed root, and I'm going to make this 1 over 1,000 to the negative 2 power. The cubed root of 1 over 1,000 is 1/10, because we just found here that 1 over 10 to the third was 1 over 1,000. What does the how do we get rid of that negative? Flip it. So this is 10 squared, which is 100. Okay, what about 9? Add them. So when we have fractions, what do we have to make sure? Common denominator. So 4/3 and 2/3 is 6/3. 6 over 3 is 2. So we'd get 36. What about number 10? Okay, I was seeing if anyone would jump there. Okay, we don't just subtract. Why can we not just jump to subtraction?
They're not the same.
Not the same base. So how can we make it have the same base? We actually don't want to multiply to make the same base. because we don't want to change the value of either number. We just want to rewrite it in an equivalent form. Think about 8. Can we turn 8 into 2 to a power? What is it? 2 to the third. So we'll have 2 to the third to the 12th over 2 squared. Using our power rules, we'll multiply these together. So we'll get 2 to the 36. Now can we subtract? Yes. And get 2 to the 34th. And I'm not going to worry about what that actually equals. We're just going to stop there. But you guys do have your scientific calculators available to you to actually multiply out if you need to. Is it? Oh, I thought you found it. It might be one of those ones that comes back in scientific notation or like syntax error because it's too big. All right, what about 11? How might we approach that one? So if it helps, you can write it as the fraction. What do we have to do with the exponents since the bases are the same? Subtract them. Can we subtract root 2 and root 18? No, not yet. Can we simplify the radical so that we can? How can we simplify square root 18? 3 root 2. So we'll have root 2 minus 3 root 2, which will give us negative 2 root 2. And I'm going to say we're okay with negatives at the moment. And what about 12? What would we do there? Robert? Subtract the exponents. So 7/3 minus 1/3 is 6/3, which is 2, so 49. So a lot of what you're going to see on your worksheet, it's going to be your basic properties, but you're going to have some weird numbers. Like you're going to have a lot of fractions, you might have some radicals, but the properties that you're using are the same ones that you've done since 8th grade, 7th grade. The other thing, so that's what you're doing on this whole front side. So 1 to 28. Are you doing all of these or just some of them? Odd? Okay, that's what I thought. I didn't think you were doing all of it. Okay, so that's what you're going to do on the 1 to 27 odd. On the back you have true, false, and graphing. So I wanted to run through just a couple of true, false so you kind of saw what to expect, as well as a quick graph or two, just to recall how we did those. So when it comes to the true, false, you're really looking to see, is there a way that we can turn one side of the equation to match the other using our exponent rules? So when you look at something like 13, is there any way that I can turn 4 to the x into something using an exponent rule to match up with 2 to the 2x? So you want to think of your exponent rules to see what might you be able to do. So anyone think they have an idea as to how we might be able to make those equal? Robert? We're not solving. We're not solving. We're trying to see true or false. Are these equal statements? Like, does this in fact equal that? How do you know that? Madison just figured it out.
Because 2 to this 2 squared is 4, and then the x stays, so 4.
So if you worked over here, you can rewrite this as 2 squared to the x, which is 4 to the x, matches that side. Or you can think of it as, rewrite this as 4 is 2 squared to the x, which gives you 2 to the 2x. Doesn't matter which side you work with, you just want to see, can you use your exponent rules to turn one side into the other? If you can, you would say true. If you can't, you say false. So if we look at 14, is there a way that we can turn the left into the right or the right into the left? So we have 2 to the x plus 2 to the negative x equals 2 plus 2 to the negative 1 all to the x. Kurt's shaking your head no. Why?
Because the 2 to the negative 1 on the right side of the equation would make that a 1/2.
Mm-hmm.
So it wouldn't work.
Would that not happen over here? Oops. 1 over 2 to the x. You're right, it's a no. Does anyone see which property they tried to use but used it incorrectly?
Distributing.
They tried to use that when you have a multiplying and you put it to everything. They tried to do that one backwards, but is everything inside being multiplied? No, which means you can't just take the x out because of this addition sign right here. So this one is in fact false. Okay, what about 15? Can we make those the same? No? Abby says yes.
Yeah.
Isabella says yes. Anyone else have a thought? Abby, how can we make it the same?
You can use 2 as the exponent of 3, and then distribute that.
So-
1.
And then when we multiply those, we have to distribute. And it matches. So that, in fact, would be true. Okay, and what about the last one, 16? You sit behind Jennifer. True or false on that one? Everybody say no? Why do you say no? So you're right, the bases aren't the same. You're very correct on that.
Should it be 20x plus x? Or
It would be, well, the only way we could add the x's would be if the bases were the same. And they're not the same, so it's not x plus x. This one's a true. Think about what did we try doing up here? We tried taking out the exponent, but it was addition, so we couldn't. Multiplication, what do they both have? The exponent of x. So that would be the same as 5 times 4 to the x power. So if we undistribute it, then we can multiply the 5 and the 4 together to get it to match. So a lot of these, you want to start thinking of your exponent rules backwards on some of these to help you see whether or not it's actually a true statement. So that's what 29 to 45 odd is, just true false. So you're going to just try to see, can you rewrite the right side like to match the left or the left to match the right? And then the last three, you're sketching graphs. So when it comes to sketching graphs, what's your go-to if you can't remember how to do it? A T-chart. That's not, well, decimal sometimes will have it come up. So in exponential graphs, usually my go-to is a T-chart. Just because you can usually pick like 2 or 3 points and have your graph. So what's the easiest one to pick? 0. Anything to the 0 power is?
1.
All right, so I know it crosses at 0, 1. What's another easy number to pick?
1.
2 to the first. So 1, 1, 2. Okay, what's another one? Okay, 2 squared is 4. Okay, but we do want to make sure that we also pick some on the negative side. So I usually pick 1 negative, 1 positive. So let's pick negative 1. What's 2 to the negative 1? 1/2. This is, exponential graphs are ones that have an asymptote at the x-axis. Unless obviously it's shifted down, then you won't, but you'll have a horizontal asymptote at some point. And then only difference between 17 and 18 is our direction. So here we had 2 to the x. How is our graph going to change when it's 1/2 to the x? Anyone remember how the shape of it changes? Instead of going like this, it goes like, instead of this, it'll go like this. Okay, so same thing. We can start with 0, and we get 1. But this time when we pick negative 1, what happens? Bless you. 1/2 to the negative 1 becomes 2. And so then when we go and plug in 1, we get 1/2. So it just switches your graph. Instead of going from low to high, it goes from high to low. And it's just the fact that it's a fraction in there. So the last 3 are going to just be sketching graphs like this. Just make a T-chart with maybe 3 points in it, and you're good. We don't do a whole lot of graphing in this. This is just to remind you what an exponential looks like.